Hello.
Yeah,
Yeah. So, I have started the live streaming. So, good morning, everyone. To all the members who have joined through WebEx as well as YouTube. Today, this is our third technical session of the month, which is on remote sensing and which will be taken by our very own GeoGuide theme developers. So, over to you, Sahil sir.
yeah. I request all to please mute their mic. Yeah. Good morning, all. So I'm Sai. So I will be taking this session remote sensing, and along with me we have GeoGuide team developers Shama and Shashwat. So yeah. So I will be covering the basic overview of remote sensing, what remote sensing is, and little details about the remote sensing. Okay. Uh, okay. Yeah. So today's content, I will be covering what is remote sensing, what is space-bound remote sensing, then optical remote sensing, satellite image processing, and machine learning and deep learning applications for remote sensing. Okay. So yeah, in the next slide, we have a short video. So I hope everyone must have watched this video. Yeah. So any guess what was this video about? I think it was clear from the name itself. Uh, I don't think they have chat access, right? Okay. Cool. The video, yeah, the video was from Chandrayaan 3, which was launched recently. So on August 5th, it just entered the moon's orbit, and it took few photographs of the moon when it was moving closer by to the moon. So yeah, so that was so this is also a remote sensing. So now let's see the basic definition what remote sensing is. So remote sensing is basically acquisition of information about an object. So without being physical contact on the ground or on the nearby object. So so it's different from in situ measurement. In situ measurement, what we do is we place a sensor wherever we want the reading. Let's say we want to have a reading about humidity sensor, like the moisture content of the soil. Then we can use soil moisture sensor. So that is in situ sensor because we are having direct contact with the object from which we want the sensor reading. But in remote sensor, we in remote sensing we don't have physical contact. We get the sensor data without being physical contact with the object or the ground. So remote sensing collect electromagnetic radiation within its IFOV. So what is IFOV? IFOV is instantaneous field of view. So so it basically remote sensing can be divided into two types, like mostly satellite remote sensing and aerial remote sensing. In satellite remote sensing, you have satellites which are revolving around the Earth, and which
ನಾನು ಊಟ ಮಾಡೋ
uh, I just request to please mute your mic, please. Yeah. So in satellite remote sensing, you have a satellite which is revolving around the Earth and which takes images of Earth or any other planet, and it uh, takes the information of that particular area. So in what is instantaneous field of view is like you can see the sensor which is collecting information about this area. So instantaneous field of view is the ratio of the ground distance, let's say this distance, to the height of the sensor. So this is for every individual sensor particle on this satellite. So that is instantaneous field of view. So it gives you like what could be the spatial resolution. So what is the resolution? So you can determine resolution from this IFOV, instantaneous field of view. So satellite will have a little lower instantaneous field of view because it's located at a very high distance. And with aerial imaging, you can get little better instantaneous field of view. That is, you can get a very high resolution of image because it is very closer to the surface on the Earth. So now I was talking about the Earth. Similar thing can be done on other planet. It depends upon the atmosphere and uh, if aerial vehicle is supported on. Yeah. So you can have satellite imaging, then you can have aerial remote sensing, then you can also have UAV based remote sensing. So this is now becoming popular using drones and all. So in aerial, you just fly a plane over the area and you capture various images of that area. So yeah, that is the basic overview of the remote sensing. Yeah. So then remote sensing is divided into two types mainly. That is passive and active. So in passive remote sensing, we are dependent upon the source light, and in active remote sensing, we have our own source of radiation, light or radiation. So in passive, we have dependent upon the radiation. So mostly radiation from the sun, because in the solar system, our sun is the brightest star, which provides a lot of radiation. And uh, passive remote sensing can be further divided into dependent upon the reflected light, thermal emission, and passive microwave. So in this is basically optical remote sensing, thermal and reflected. So thermal and reflected is a part of optical remote sensing, which is dependent upon the uh, passive light. So in reflected light is dependent upon the source of light, but in thermal it's not dependent upon the source. Like you can say passive, but it's not dependent upon the source of sun. So in reflected light, it is the reflected radiation, which is uh, reflected from the surface of any planet or the Earth surface. So reflected light in this, there are various categories. Like you can have aerial photography, you can take visible or near infrared. So visible light is whatever visible light we see, and we can also have near infrared, which our eyes can't see, but you can see from the your mobile cameras also the infrared radiations. And then you can also have SWIR, which is shortwave infrared radiation, and which is near to the infrared radiation. So we can't see the infrared radiation, but our cameras can see. So this can be used in satellites as well as the aerial photography. And in thermal emission, you are not dependent upon the solar radiation. Like you can have thermal imaging dependent upon the heat radiated from the object. So you don't need a sunlight or a radiation, reflected radiation, like source of light to have this kind of imaging. And in passive microwave, it's a microwave remote sensing in which there is no active source of light. That is, you are not using any source of source of radiation to get the data. So that is passive microwave. So microwave is a like in the electromagnetic spectrum we have microwave radiation part. So that is being used here. So radio waves mostly, and in active we have our own source of light. That is, we are not dependent on the other source. Let's say sun or other source of light. We have our own source of light. The example can be invisible or IR. It can be laser. LiDAR. LiDAR is a good example. Laser profiling and LiDAR. So LiDAR, you must have seen, it has its own source of light. It uh, sends its own source of light, and the reflected light is detected again by the sensor to get the profiling of the image. So then in active, it can also use microwave region. So in active microwave region, you have ultimately scattorometry, synthetic aperture radar. So this is basically, it has its own source of light. That is, it sends its own source of light to the surface. Let's say, if we are talking about the Earth, we can have a satellite which is revolving around the Earth, and it sends its own source of light to the surface, and that light is reflected or scattered back to its sensor, and that is being detected to get an image. But in this reflected light, it depends upon the solar radiation. That is, whatever light which is reflected from the sun, like reflected from the ground surface, the reflected light of the sun, solar radiation, and which is being captured by the sensor. So it doesn't have its own source of light. The satellite doesn't have its own sensor source of light. It uses the solar radiation. So that is the main difference. And mostly remote sensing is divided into two main types: optical and microwave. So optical deals with the solar radiation and thermal imaging, and microwave deals with the radio waves. Yeah. So before this, I have few questions. So maybe yeah. So just a small quiz to test your general knowledge. So you can just scan this QR code, and you can give your answer. So what is the first satellite that went outside the solar system? So are you able to scan this QR code? Uh, can someone react? Yeah, you are able to do this. Yeah. Yeah, don't Google it. Just you can guess if you don't know. That's fine. This doesn't have any. This is not evaluated for your certificate, so don't worry. This is a
क्वेश्चन क्या
whole
है
interaction.
क्वेश्चन क्या है
Please mute yourself. Yeah, just one more minute. Okay, 85% have voted Voyager 1. Yeah, 20 seconds more. Okay, cool. Then the answer is Voyager 1. So Voyager 1, uh, please mute yourself. So Voyager 1 was the first satellite. So that is outside our solar system now. So it is an exoplanet, like it is going towards the exoplanet. Okay, yeah, let's go back to our slides. Yeah, so I have one more question now. This is just a poll. So I have two images here. So this one and the other one. So this is an image of a Kuwait. So this is a Khalifa International Stadium where we had FIFA like football game last year and FIFA World Cup. And the other image is of Mumbai area. So this is the Mumbai area. So the question is like which one is the satellite image and which one is the aerial image. So uh, you can oh, just a second. Right. Yeah. So which of the following is an aerial image? So image one was of Kuwait, which was international stadium, which had a FIFA stadium, and the other person was Mumbai. So which one was the aerial image? Yeah, you have 1 minute. Just give your polls. So I'm sharing the screen again. So this was the Kuwait map, and the other one was the Mumbai area. Just observe, just observe carefully and just mark your poles. Okay, you have 10 seconds more. Okay. So the answer is Mumbai. So let's see how. So the hint was on the slides only, but I think you have not observed it. So if you observe this source, you can see this image is from ISRO. So this is a satellite image, so which is captured by Cartosat 3 satellite. So which is this is a very high resolution image. So every pixel on this image is like each pixel is 25 centimeter. So if you see a pixel, it covers 25 centimeter of the land. So that is the state of the art resolution that we have now. Uh, so various space agencies are working to improve this resolution. So you can see that how distinct this image is and how clear this image is. So you can see the every details of this map. This is basically a fused image. So they have used two types of images and they have fused to generate this very high resolution image. And the other is the aerial image, which is captured by the drone. So this is the Mumbai area, so which is captured by a photographer using his aerial drone. Okay, so next is electromagnetic radiation. So little bit of physics. I think everyone of us have learned this. So we have electromagnetic spectrum in which we have radio waves, then infrared waves, then visible light, ultraviolet light, X-ray, and gamma rays. Uh, in remote sensing, mostly we are interested in visible, infrared, and radio waves. So we are not interested in this part. This, uh, please mute yourself. Yeah. So this part of sector is mostly used for medical imaging and all. But in remote sensing, we are only interested in this part of spectra, which is visible, infrared, and microwave. So, if so, every planet has its own like advantage and disadvantage, whatever we call it as. On Earth, we have something called as atmosphere. I think we all know what is atmosphere, right? So it's a layer of layers made up of various gases. So because of this atmosphere, we are like restricted to certain wavelength of light that we can capture back. So in this image, you can see there is certain window that is available for us to capture the light, to capture the radiation. So we have visible radiation. So in this, we can the satellite can capture the visible light. So this is a small window that is available. So because the other window is not available, as in blue, you can see it is blocked. So you can't have remote sensing done in this area due to various factors like the atmosphere scatters or reflect or refract certain part of light. So you can't do remote sensing in those areas because if you are doing, let's say you are using this band. So this is a band which is very close to the visible, and whatever the atmosphere layer is. So every atmosphere layers has its own reflectance and scattering property. So it will destroy the light. So you won't be able to capture the light back to the sensor. So you can't use this part of region, this towards the ultraviolet region, for remote sensing on the Earth. So you have to use only the region that is available, that is this visible small band. Then you have very small area, very narrow area on the infrared regions. So these are the infrared window regions. So because the atmosphere blocks certain infrared region, So very fine bands are available. So you can use that particular wavelength of light to get to detect whatever reflectance you are measuring. And then you have in microwave window, you have a small gap, and then you have this window. And in radio wave, you have very large window available where you can use your microwave remote sensing to detect whatever remotely object you are measuring. So due to the uh, yeah, so so yeah, so atmospheric window is a window that basically blocks the radiation. So you won't be able to capture all the light uh, you are getting back reflected from the Earth's surface. Only this window, whatever is available, you can capture that using your satellite sensor. But if you're using aerial imaging, you don't have this because atmosphere doesn't it won't block your aerial image because aerial image is very closer to the ground and it won't be accepted by the atmospheric layers. So yeah, but this is only for the satellite imaging. So every planet has its own atmosphere. Like some planets don't have, but most of the planets have its atmosphere, and it has its own signature. So this blockaging is of depends upon the planet, what atmosphere it has, what is the layer, what is the density, and all, and so it depends upon the what wavelength that you will be using to read the data. Then you have atmospheric correction. So let's say this is a sun. So you are getting a solar irradiance. So irradiance is basically the light which is getting the light source you are getting from the sun, which is getting on a particular area. So you have a sun and you have a light source. So that is this is the atmosphere band, and the light source enters the earth through the atmosphere. So it reaches the target. So this is a target area. Let's say you want to read this area. It reaches this area. Then there are various other parameters, various things that is happening. That is, once it enters the atmosphere, it has been refracted. So there is some parameter which is there is a light of there is a loss in the source of light, and then again you will have the light reflected. So the reflected light will again go into the atmosphere. There will be again refraction and other activities going on, and then it will go outside the space, and then you have a remote sensing satellite. So this is a satellite which is orbiting so around the earth, and then you will get this data. And in between there is also other process, like let's say whatever light is being absorbed by this surface, like reflected by this surface, for reaching this surface, it is also being reflected to the other area, like you can say scattering, and also the light which is being scattered by the neighboring area, which is also being soaked into this. So this is a neighboring region. So let's say the light is also coming to this region. So this light is also being reflected into this region, and then again this region acquires this source of light. There is not a direct way of getting the proper radiation reflected. There are various scattering parameters which is happening. So you can also have the light diffused in the sky. Let's say as we know in the earth, like we have due to the atmosphere, we have various scattering, like Rayleigh scattering, E scattering, or non-selective scattering. So due to this, there are various source of light which is being coming onto the surface, and then again you have various light reflected to the sensor. So whatever light which is reaching the satellite is not a direct source of light which is being reflected from the surface. It has various other scattering parameters. So what space agency does is it does a lot of atmospheric correction. So whatever satellite image you see, it's not the direct raw image that is being captured by the satellite. Space agencies do a lot of corrections of the atmosphere because our atmosphere is so complex. So they do mathematical modeling of the atmosphere, and they do correct a lot of imaging and all. And then whatever image you see is the corrected image using atmospheric modeling. Uh, then you have two types of satellite mostly, polar satellite and a geosynchronous satellite. Polar satellite is also called as sun synchronous satellite because it revolves around the earth from one pole to another. So it is at a distance of 500 to 800 kilometer. So this is very close to the Earth. So the advantage is that you can get a very high resolution image as it is very close to the Earth, and uh, this is used for most of the purpose. Let's say for getting a very high resolution image for mapping, or to see a particular area and get a very high res. So it has very high temporal resolution. So I will define what is temporal resolution in the next slide. So it has you can get image of after particular region because it is revolving continuously around Earth. Then we have a geosynchronous satellite, which is a geostationary satellite because this satellite is very far away from the Earth. So you can see that altitude is approximately 35,786 kilometers to 42,000 kilometers. So it is very far away from the Earth, but it is capturing particular region of the Earth. Let's say I want to see uh, borders of India, like international borders of India. So I don't want my satellite to be continuously revolving around the Earth. If that is the case, then I won't be able to capture the particular region of interest that I want to observe. So this satellite is used, geosynchronous satellite, to mostly for defense and weather forecasting purpose. Let's say I want to see the weather. I want to study the weather of India or its neighboring region. So I want my satellite to be stationary on that region every time. So this satellite is in sync with the Earth. So its time period is same as the Earth's time period. While in the other case, this satellite is revolving continuously and it is very close to the Earth. It has very high resolution capability, but this doesn't have very high resolution capability because it is very far away from the Earth. Uh, then I have one more quiz, like a poll. Yeah. So as we know, there are the file format for images, mostly PNG and JPEG. So what do you think? What will be the file format for a satellite image? Uh, you have 1 minute. Just give your poll. There can be multiple answers for this. You can select multiple answers. Okay, 10 seconds more. Yeah, the time is up. So the answer is both intuitive and binary. So satellite image is most like the image that we normally use, but the only difference is it has latitude and longitude associated with it. Uh, uh, if you see a satellite image, so every pixel in the satellite image has a latitude and longitude associated with it. So that's why it's called geotiff. So TIFF is a format of image, and geo stands for geolocation. So the most common format that we use in satellite imaging is geotiff, and the other is binary. So you can also use. So there are also binary format that space agencies provide. So mostly this corrections and location association, all this is done by the space agency. So basically, satellite captures the raw image, and then it sends this image in a small data stream. But because you can't send entire data, you can't send the entire data to the ground station. So uh, please mute your mic. So if you have any questions, just type in chat or you can ask at the end. So yeah, so this satellite basically takes a image and then it stores in its onboard, let's say, memory. And then whenever it reaches a ground station, it sends the data stream to the ground station. And the ground station, there are various scientists which are working on that, and they convert those data into a satellite image. So they do a lot of atmospheric corrections and also uh, data stitching, like because satellite captures a particular area, not an entire, because as it is moving, the satellite is continuously moving, and let's say in polar satellite, so it captures particular area. So then that area is being stitched, like whatever data is being captured of that area, it is being stitched to generate an entire big image that is also called as mosaicing. And whatever latitude and longitude associated with it is been associated to the pixels. So so a lot of work is happening on the ground station also. So that's why you can't have direct, very live image from the satellite. It takes at least 5 to 6 days by very high tech companies like Maxar Technologies. I think you must have heard Maxar Technologies. In Google Earth, if you see the satellite images, so basically Google Earth uses satellite images from Maxar Technologies, Sentinel, or Landsat. So these are the three. Sentinel, Landsat are, so Landsat satellite is from NASA. Sentinel is from ESA. So ESA is European Space Agency, and Maxar is an independent company which is working on space tech. So yeah. Uh, so yeah. So where I'm, so now where you can get satellite image data freely available. So there are a few websites where you can get this data available. Of course, you can't get very high res image and very live images. These images can be of few months back and should not be very, it won't be very high resolution, of course. So these data are available for free. So NASA has its website, USGS Earth Explorer. So if you type USGS Earth Explorer, you will see a website where you can log in and then you can get satellite image of particular region. Like you can select a map canvas, like on a map canvas, you can select particular patch of land. And if satellite has gone through that region, you can get the image of that region. So it has various sensor data logged into that portal. And the other is ESA, European Space Agency. It has its website EO browser. So it has images of Sentinel Hub satellite, which is from European Space Agencies. So in EO browser also you can get satellite data uh, from that portal. And from ISRO you have Bhuvan. So Bhuvan is a website from which you can get all the data of weather related imaging or the normal RGB image or IR image. And then you have Google Earth Engine, of course. So I think every one of us have explored Google Earth. So, yeah. So these are the source of websites where you can get the satellite images. Next, you have types of satellite images. So you have mostly three types of satellite images: panchromatic, multispectral, and hyperspectral. So the one on the right side, so this image is of uh, covering Mumbai region. So this is somewhere Mumbai region. Yeah, this is Mumbai. This is, I think, Bandra ceiling. So this small part, and this is entire Mumbai region. And we are situated here somewhere. This is IIT Bombay. This is IIT Bombay region. So this is basically a satellite image. So this is a multispectral image. This is a multispectral image. So what is multispectral image? So multispectral image is, it has various bands. So in a normal camera we have just have three bands: R, G, and B, red, green, blue. But in satellite we have various bands because as I said, like particular regions, like particular objects, it's basically physics and chemistry. Like particular objects reflect particular light. So whatever we see is due to the reflection of the light from the object. So we are also interested in other bands which our eyes can't perceive, but we can use that band and convert the data collected from that band into the region that we can see. Like as we can only see RG and B, like the color gradations of the RG and B, the color visible light. So what we do is we convert the infrared region into the light that we can see. So here, whatever red light you are seeing, so that is vegetation. So it is near infrared band. because as we can't see near infrared band, so we convert those into the visible region. So mostly the images are red, green and blue. But here, whatever image you are seeing, it has bands NIR, near infrared region, red and green. So what we do is we associate this NIR band with the color composite that we can see. So that is called false color composite. So we have associated NIR band with red. So NIR stands for near infrared. So we have associated near infrared band with the red region. So that's why whatever vegetation you see, these are in red. So because vegetation reflects more in the near infrared band. So that's why whatever green region you see, it is red in color here. And then we have red. So whatever red light is reflected, it is being the color given is green. So we are giving false color composite. It's not the real color that is being reflected. This is used mostly for image interpretation, so that we can interpret image what actually is there. And then for blue region, we are giving green radiations. So that is false color composite. So we have denoted NIR with red, red with green, and green with blue. So that is the false color composite. And then we have panchromatic image. Please mute yourself. I will take questions at the end. If you have any questions, just note down and ask again. Then we have panchromatic image. So in panchromatic image, so the sensor. So in multispectral, there is basically bands apart from RGB. So there is red, green, blue. There is also other bands which can be used like infrared or near infrared, short wave infrared. So these are mostly the bands that are short wave infrared, band 1, band 2, band 3. So mostly those frequencies, the wavelengths of the light, particular bands are used to detect various applications. Let's say water reflects particularly in the sphere like short wave infrared band and blue region. So you can use that for your application. And the vegetation reflects in the near infrared region. You can use this application, this band. So whatever the satellite is being built, it is been like designed. The sensors are designed so that particular bands, like whatever areas of interest is, you can use that. And then we have panchromatic. In panchromatic, you capture all the band, like you have an entire huge band. You capture data on that entire huge band. So it doesn't have like various small bands like multispectral. In multispectral data, there is finite bands which are being used, let's say 8 or 9 bands. But in panchromatic, there is a single image which is being captured over a particular band of region. So it has like very high radiation which is being coming to the sensor, because as it has a very high bandwidth, so the sensor can collect most of the data. So this was a panchromatic image. And whatever region like image you see, particular band, it is basically grayscale image. So then we give color composite and we visualize it. So even in our normal camera RGB, it's a grayscale image. Then we give a particular color to that red, whatever bands have been captured, like red, green, and blue, and then we observe in our monitor screen. So, and then we have hyperspectral image. In hyperspectral image, it has a contiguous band, meaning it means that it has very small bands at a very small intervals. So it's like continuous bands which is being captured. It's not exactly continuous bands. It's a very small bands which is being captured, and then you can have various image layers. So you can see a 3D image. It looks like a 3D image as images are captured at various bands. This is hyperspectral imaging. So mostly we have 3 types of image. This is panchromatic at the center. Then we have multispectral image which has 7 to 9 bands, and then we have hyperspectral image which has more than 200 bands. Then we have resolution. Like satellite image processing, we have resolution. So spatial resolution. So what is spatial resolution? Spatial resolution is the resolution of the ground surface that you observe. Like in the image you see, like whatever image I was shown of the cuvette and the aerial image. So the resolution what you saw in the image, the 25 centimeter what I told, it's a spatial resolution. Like it relates to the space on the ground. That is spatial resolution. And spectral resolution. So it will be more clear in the next slide. I have images to show, which will give you more clarity. In the spectral resolution, you have spectra of images. Let's say in this multispectral, you have 8 to 9 spectra. In this hyperspectral, you have 200 spectra. So it relates with the wavelength that is being used. That is spectral resolution. So more the bands, more is the spectral resolution. In radiometric resolution, it is the uh, radiometric value, like whatever ADC. In ADC, you have particular data that can be captured, right? Particular like 10-bit data or 2-bit data or 4-bit. So that is radiometric resolution. It is the amount of the capability of a sensor to capture the data and store it. In temporal resolution, you have how like what time interval the satellite takes to capture the data. Let's say in polar satellite, it is being continuously rotating. So it takes at least 15 days or 30 days to reach the same place. So it's the capability of satellite to capture the data of a same place. The time taken by the satellite to capture the data of the same place. That is temporal resolution. So the geosynchronous satellite has good temporal resolution because it is observing only at a same location. And in satellite imaging is like a normal image, except that it has latitude and longitude, and it's very huge. Like it is capturing data of a very long area with very high resolution. So the data will be very large. Like a single image can be of 2 GB or 3 GB. Let's say a particular Mumbai region captured at a resolution of 10 meter. The data can be of 2 GB in size. The image can be of 2 GB in size. Uh, so you can use various image processing techniques. So you can do image enhancement, you can do image classification, you can do image segmentation, you can do morphological operations, etc. So these are normal image processing techniques. I think you must have uh, gone through the image processing tech talk yesterday or day before yesterday. Yeah. So normal image processing techniques can be used on it. So don't worry, we have tools to do this. You don't need to write OpenCV script. Of course, you can do that. You can use OpenCV to various operations. Yeah, please mute yourself. I will take the questions at the end. Yeah. Uh, so yeah, so as I told I talked about the resolution. So here are the images. So on the right side, this image, this is a spectral resolution. So this image is of vegetation. So it's a reflectance which is the wavelength. So on the y-axis we have reflectance, on the x-axis we have wavelength. So like every object on any on any other planet, or on the Earth, it reflects to a particular band, like particular wavelength of light. So it has its own signature. So how ISRO designs the sensor is the need for the data to be captured. Let's say we want to detect moon on the we want to detect ice on the moon. So then they will design a sensor in such a way so that the data which is been reflected, like the radiation which is reflected by the ice, is so the bands they will select of that particular region. So here you see vegetation. It reflects in particularly near infrared region. So you can say this is a healthy vegetation. And if the vegetation is not healthy, you see the reflectance is low and the signature has been different. So in this way, you can study the vegetation and other uh, areas of interest. Let's say you want to find a particular gemstone or other stone on the planet or on the Earth. So you can study the signature and you can design a sensor and you can send it on the space and you can detect the particular signature and find what object is there on that particular planet, and you can then have that data. So this is a soil, this is a healthy vegetation, this is unhealthy vegetation. Yeah, and here on the left side you have a spatial resolution. So as I said, this is a 1 meter resolution, this is a 10-meter resolution, this is a 30-meter resolution, this is a 250 resolution. So lower the this resolution, like higher the resolution, you will see more details on the image. So 1 meter scale will have few more finer details been seen than the 10-meter image, and then the 30 and yeah. And then you see at the bottom is the radiometric resolution. So more the radiometric resolution, more clarity on the image, because more data is being associated with that particular pixel. So 8-bit pixel in so every pixel is associated with the 8-bit data. So you can get more clarity on this image, more grayscale gradients on that image, and you can see more clarity on that. So this is radiometric resolution, and this is temporal resolution, the capability of a satellite to reach a particular region over a period of time. Yeah. And then image interpretation tools. As I said, there are various tools available. So you can use Snap or QGIS, which is an open source tool to do all the image processing. Let's say you want to enhance the image, you want to do histogram analysis or do any other image processing technique. The tools are already available. You can just pick that and use it in these tools. And you also have NV and ArcGIS. So these are proprietary tools. Snap and QGIS are open source. And then in microwave, you have a microwave region. As I said, mostly satellite imaging deals with optical and microwave. In the microwave, we have two tools, NV and Pulsar Pro. So these are also proprietary tools. We don't have open source tools for microwave. And then applications. So this is the most important part where I think you all must be most interested in. So on our Earth, basically our Earth is made up of these 5 spheres: lithosphere, biosphere, cryosphere, atmosphere, and hydrosphere. So lithosphere deals with the lithos, that is the stone region, like the rock region of the Earth, and biosphere deals with which is between the atmosphere and the lithosphere, which is where we are in. And then we have cryosphere, which is the ice on the planet or a planet, and atmosphere is that region over the biosphere, which is layers of gases on the Earth. And then we have hydrosphere, which is water. So there is a lot of application on all these layers on the Earth, to study all these layers, to get the details of all these layers. The application can be agriculture. Let's say this is a farm, you want to detect the health of the farm. So you can use a satellite image. You can get the readings from the NIR band and the red band, and then you can calculate the vegetation indexes, that how healthy this farm is, how greenery the water, like how greenery the vegetation is the vegetation proper or is healthy or not. So that you can do. So you can use various image processing techniques. You can also use machine learning and deep learning techniques to do that. And then you can, in forestry, then you can count the trees and also detect the forest fire. So in the right side, you see this is a forest fire. So whatever brown part is, it's the forest fires. The green part is the vegetation, healthy vegetation. You can also do mapping using satellite imaging or aerial imaging. So you can map the particular area, and then you can create a map that can be used for navigation. You can also create a 3D map of a particular region. You can also create a digital twin, which is the exact replica of a particular region. Whatever 3D structures you see in the game engine or Google Earth, that is basically you call it as a digital twin. It is the exact replica of a city or a village of that particular region, 3D replica. And then you can also use for geology purpose. Let's say you want to detect the hydrocarbons, petroleum or gas, whatever gas you want to mine it. So you can detect it via satellite. You can, like as I said, particular object reflect particular spectra. So you can study the spectra of hydrocarbon, and you can find where you can get the oil, like hydrocarbon oil on the Earth. So there are various applications. You can also use for hydrology, like you can also detect where water can be, where is the like soil moisture, like what moisture content is present in the soil, or where is like most scarcity of water and all. So that you can study using microwave remote sensing. So microwave remote sensing had its advantage as it can be penetrated through the clouds and the all the obstructions on the Earth. It can penetrate through certain distance inside the cloud also. So a lot of research has been happening in microwave remote sensing also. And yeah, you can also use it for land use and land cover application, like what part of land is occupied by the people and how much area is available and all. Yeah. And then you have the important part is machine learning and deep learning application for remote sensing. So, so machine learning is basically used to automate the things, right? So you have the data. So you have like the normal way of doing is like you have data, you have a program, you write your program, and then your computer use that program to understand the data and give you the output. But in machine learning, you have the data, you know the output. This is the data, this is the output. Your computer creates a logic. So it's like a computer creates a logic to understand if given data is in, then what could be the output. So it's like it's creating the program. You are not writing a program for it. So that is the machine learning advantage. So this is just analogy. So yeah. And then in machine learning, you have three kinds of learning: supervised learning, unsupervised, and reinforcement. I think all of us know this because you all must have done various courses on machine learning, NG and all. So yeah, so this is just a brief overview. Like what is supervised learning? You have a data, you know input data, you know the output data. So you have a labeled data in it. In unsupervised learning, you don't have the label data. You just have the data, and you from the data you try to understand what could be the output. And in reinforcement, you have an environment, so you try to understand from the environment and then try to improve your learning. So that is reinforcement learning. So basically, the entire Venn diagram for this is the artificial intelligence, which contains machine learning and deep learning. So artificial intelligence has ability to imitate intelligent human behavior. And then in machine learning, it's application of AI that allow you to automatically learn and improve from the experience. And in deep learning, you have machine learning, like it's the application of machine learning that use complex algorithms and deep neural networks to train the model. So this is very much blooming now, deep learning. And so basically, machine learning deals with representation, evaluation, and optimization. So representation is like set of rules, logics. It can be neural network, it can be support vector machine, it can be ensemble learning, it can be also logistic linear regressions. It can be anything. Evaluation is like evaluating your accuracy. It can be evaluating your accuracy, precisions, or errors. And then optimization is like optimizing your network, like optimizing your algorithm to get more realistic data. So you can use gradient descent for convex optimization. There are also various versions of gradient descent algorithm. So you can like I'm not going into the more detail of this. I'm just giving the brief of what are the things that
ಚೆನ್ನಾಗಿಲ್ಲ ಚೆನ್ನಾಗಿಲ್ಲ
uh,
ಚೆನ್ನಾಗಿಲ್ಲ
just mute yourself, please. And then
ಅದೇ ಗುದ್ರ ಹೋಗ್ಬಿಡಕ್ಕೆ
you have various machine learning
ಅಡ್ವಾಂಟೇಜ್
algorithms.
ಆಕ್ಚುಲಿ ಇದೆ
So here's a brief overview like what algorithm you can be used.
ಏ ಕೆಫೆ ಸರ್ ಹೆಂಗಿದೆ
Please,
ಹಾಲಿಡೇ
checking someone's mic is on. Oh no, please mute yourself. Yeah. We have classification. In classification, we have various algorithms. You can use convolutional neural network. So there are various models based on convolutional neural networks like BGZ16, Inception, ResNet, Efficient Net. In classification, basically you classify various objects from the image. In segmentation, you have various models for segmenting the image. So these are all the deep learning models that I've mentioned here. So you have SAM, which is from Meta, segment anything model. Then you have UNet. So these are the most popular segmentation model. And then you have generative learning, which tries to create a new uh, artifacts from the data. So mostly GANs, generative adversarial networks, and diffusion model. So diffusion model in that, I think you must have heard DALI 2, which is from OpenAI. It creates generative data. So these are used for generative learning. Then you have time series data, which is based on the series of time. So you can use RNN. So it can be used for natural language processing and also for other speech or recognition and all, translation, speech recognition, etc. So you have LSTM, long short-term memory. You have LLM, large language models. So ChatGPT and BARD is based on large language models. And then you have 3D reconstruction. So in 3D reconstruction, there is a popular algorithm NURF, neural radiance field, which tries to create a 3D reconstruction using deep learning technique. So these are all the basic models, most popular models, which can be used for remote sensing analysis using deep learning techniques. So here's the example. So this is a satellite image. You can see this is a particular airport. Various images are being detected, and it has detected the name of a flight, like the plane, uh, using deep learning techniques. So it has classified various planes as per their classes. So you can see various types of fighter planes, normal planes, and you can also segment the image. So from the satellite image, you can segment the image. Like you can see buildings areas are marked in red, and then roads are marked in yellow. So large vehicles are marked in blue, and water is marked in blue. Trees are marked in blue. So you can segment the image using segmentation algorithm. So you can also use change detection algorithm. So here unsupervised learning was used to change it for detecting the changes. So as you can see, there is a house here, but here was not that. So this was a time series data. Like say, as I told, satellite has captured, let's say, years back, 10 years back or 3 years back. And then this is a very recent data. And then you can find the difference and you can use unsupervised to get a change detection. And you can also improve the resolution of a image using generative techniques, as now there are diffusion and the GAN models which are most popular. So you can improve the resolution. This is a very low res image, and then after using GANs, you can see generative adversarial network. You can see the resolution has been improved a lot, and you can also convert your image to map. So this is the GANs. So GAN generative adversarial network was used here in this research paper to convert this satellite image directly into the map. So where you can use navigation, zoom it to any extent, and then you can also use it for 3D reconstruction. So you can use this satellite image, aerial image. This is aerial image. So this is a research from Google. So neural radiance field. So this is a deep learning model to get neural radiance. Like it give you multi-view synthesis from a single image. It uses multiple images, of course, but it uses deep learning techniques to improve the rendering process, and it can also use it for you can also use it to 3D reconstruct a particular region. So yeah, so that is the application of deep learning for remote sensing, and yeah, that's it. Thank you. So now I'm open for questions. So you can ask the questions. I hope the talk was intuitive. Like, must have helped you somewhere. I can't see the questions. Do they have? Yeah, I can see it now. Yeah, a lot of questions. Uh, do they have access to unmute their mic, or on the chat they can ask questions? After this, you will be having a quiz. So I think quiz is necessary for the certificates, I guess. I can see the
Yes,
question.
sir. I can't we also can't see Hindi, sir.
Uh, I can't see the questions. I don't know why, because I don't see the chats. Do they have access to unmute their mic? Shama?
Yeah, they can unmute their mic, or you can put it your questions in chat.
Yeah, you can ask questions if you have. You can unmute your mic and you can ask questions one by one.
Sir, how to go to quiz, sir?
Lot of noise from your end. Sai Krishna, there is a lot of noise from your end.
Yeah, okay, sir.
Yeah, now it was clear. Little.
For the questions, please put it on the chat. Like many people are unmuting, so the audio is not clear. So if you have any queries, please put it in the chat only.
Can you read, because I wasn't able to see the chat here. Like I don't have chat option. Don't know why.
Oh, okay. Uh, like one question is there. Is there any forum to get the data or any procedure is there?
Regarding what? Like they mentioned anything?
It is from Nagesh Kumar D, and maybe you can unmute and ask the question about satellite images.
Is there any forum to get the data or information? Yeah, you can get data from, as I said, there are various portals from where you can get the satellite image. You will directly get the satellite image, then you can do analysis using softwares like Snap or QGIS. So Snap is a tool from ESA. So it's very easy. You can directly drag and drop your image, and then you can use various tools to do analysis. And from the data you can get is from USGS or Explorer, which is from NASA, EO browser, which is from ESA, European Space Agencies, and the last is Bhuvan, which is from ISRO. So you can directly get data from there. You just need to log in, and you can select particular patch of map, and if satellite has gone to that region, you can get the data of that region. You can also select satellite, which satellite data you want. Yeah. Any other question? I think that answered your question. If not, then you can put on the chat. Is there any other question, Shama?
Yeah. So there is one question from Ashutosh. How can a geosynchronous satellite can be stationary on a specific area if the Earth is revolving?
Yeah, it's due to the force that has been acting, because there is a gravitational force. So if you are away from that, very far away from that force, so the gravitational force will be very less. So you can then somehow adjust your force of the satellite to sync with that. So this geosynchronous satellites are very far, like as I said, it's 35,000 to 42,000 kilometers from the Earth's surface. Then the gravitational, like the force acting on the satellite is very less. So the satellite can be stationary, observing at a region. Where in case of polar satellite, it is very close to the Earth. It needs to be revolved so that it doesn't fall into the, it does not come to the Earth's surface and collide with the Earth. So that's why it needs to be continuously revolving so that the centripetal force doesn't access the centrifugal force. I think that cleared your answer, right? Any other question?
As such, there are no doubts which I can see in the chat. Maybe we can go ahead with the rest of the session.
Okay. Yeah. So as you know, this time we have an interesting theme, Geo Guide. So if not, then if you don't know about this, then you can log on to portal.e-yantra.org. So you can read about all the themes about e-Yantra robotics competition. And I think today is the last date, right, for discount. So please do register by today. So see what themes you are interested in. There are various themes. Themes are basically the flavors of the technical stuff that is being taught using the competitions of particular themes. So please do check. And so this time we have a GeoGuide theme which is based on remote sensing, machine learning, image processing, and embedded systems. So it will cover like small part of all these things. So if you have any queries regarding GeoGuide theme, you can ask here. If you don't have, then we can go with the quiz.
There is one question from Harish Krishna. Is the GAN software able to freely access, and is the GAN software freely accessible for students?
Which GAN software is it?
Yeah, it is written GAN software.
GAN is a model, so it's a machine learning model. So you can use the like the snippet of code. So you can easily get, so PyTorch and the TensorFlow are the two frameworks of machine learning for Python. So you can use that uh, to create a GAN model. So basically a machine learning model. If you want to learn more about GANs, you can learn from TensorFlow blog or Medium blog. So, so just type what is GAN model, you will get it, and then you can use that GAN model for your application. Let's say the application, the image that I shared with you was improving the resolution of the image or converting the image to map. So you can read this particular research paper and you can check how GANs can be used to do that particular application. So GAN is particularly machine learning model, not a software. Yeah. Any other question? Uh, is there any other question, Shama?
No, currently in the chat, I'm not able to see any more questions. If you have any questions, you can post it in the chat. Yeah. Just a second. There is one more question. Are ML codes available openly?
Yeah, there are many, like you can easily get ML code because a lot of projects are like people are sharing the codes. You can get it from GitHub, you can get it from Medium blogs, you can get it from Kaggle. So there are various sources from which you can get the code for any other ML model, deep learning model or ML. Yeah. Is there any other thing that you want to share, Shama or Shashwat, regarding the GeoGuide theme?
Uh, okay. Yeah, there is nothing from my end.
Okay.
Okay, so I think the session is like coming towards an end. Sir, do you have anything else that needs to be?
No, I don't have anything. So
Okay.
maybe you can share the quiz.
Okay. Yeah. Before that, like we will be closing the YouTube live session now. The live will be completed by now. So thank you, everyone who had joined from YouTube. Thank you for joining. And as mentioned, please register for your IRC. And the last date for the discount is today. So please do register. And thank you for joining the session. We'll be closing the live session now. The ones who are there in WebEx, please stay in the meeting itself. We'll be just closing the live session now.
இரு